If we take a look at number 38, 38 said we want to find the GCF of 72a cubed b squared and 86a. Okay, so let's do our prime factorization. So I have 72 and I have 86. Well, 72 is 9 times 8, right? Is that 9 times 8? Yeah. 9 is 3 times 3. I'm going to circle my two prime numbers. 8 is 2 times 4. 2 is prime. 4 is 2 times 2. Okay. So then 86 is divisible by 2, and that's 23. 43, thank you. 43. 43, I believe, is prime. It's not divisible by 2, it's not divisible by 5, it's not divisible by 3, it's not divisible by 6, because that means not divisible by either 1, 2, or 3. So those two are both prime. So if I list these, and this is, I know I probably have already answered the question, but I want you guys remembering the work I expect, and you're making corrections to the work I expect if you don't have this. So then what we're going to do, you guys, my notes and the stuff I'm showing you in my notes of what I want you to do, 9 times out of 10 is not a suggestion. It's like, this is what I want you doing. How many of you guys know that? So while there are many of you that like to kind of do things your own way, a lot of places that's really awesome, not really in here, because I'm trying to train your brains, okay? So when you get to high school, when you do it, you have a very analytical mind. You're very organized. You're showing your steps. Or at least you know the steps in your head, that some of them you can do in your head, some of them you can put them on paper, depending on what your teachers require. So I need you doing it the way that I'm teaching you. All right, so 72a cubed b squared is going to be 2 times 2 times 2 times 3 times 3. And then a times a times a times b times b. So there is 72a cubed b squared. And then underneath that, right underneath it, I'm going to do 86a, which is 2 times 43 times a. Well, they only have a 2 in common. And then they have an a in common. So my GCF is 2 times a. And I hope that's what they told us. Yes. I forgot to check your homework? Oh, because you were helping me. All right, AJ, what was that one that you were asking about? Say that one more time. 46. Let's take a look at 46. Yeah, you've got to list those out. So that's the work I'm expected to see. So you have to list them out. You've got to circle the ones they have in common. Like, you need to show all that work. So I would practice that while you're waiting on at least one of them. Okay, so let's take a look at number 46. So 46 said you want to cover the walkway of your community garden with a square tiles. The space you want to cover is a rectangle. So we have a rectangle. Is 42 inches wide by 72 inches long. All right, and we're doing square tile. So something like this. All right, assuming that you want to cover the space exactly without cutting a tile, what is the greatest side length you can use for the tiles? All right, so our greatest side length, since these are square tiles, if these are rectangular tiles, we could not do this. Since they're square tiles, we have small tiles, we have big tiles, we can do an even bigger tile, so we have different options of tiles. But what has to be the case is that the side length must be a factor of both 42 and 72 because they are square tiles. So because of that, I can use my GCF. I want to find the greatest. So we want square tiles. We want the largest tile is what we're looking for, or the greatest tile. So that's the greatest factor of both of them, which means it's GCF. All right, so I have 42 and I have 72. Well, 42 is 6 times 7, and 6 is 2 times 3. 72 is divisible by 9 and 8. We just did this up here. All right, so I'm going to end up with my 42, which is 2 times 3 times 7, and my 72 is 2 times 2 times 2 times 3 times 3. Well, I'm going to circle the factors they have in common. So my GCF is going to be 2 times 3, or 6 inches. All right, so the maximum side length of each tile is 6 inches. AJ, does that help you? Oh, okay. That's easy to do. Yeah. $33. Okay, let's take a look at 33. It's right there. Oh, you want to know how to put them, how many of each of them are in there. Okay, so let's do this whole problem. I understand what you mean. I thought you meant the data from this table. Okay, so let's take a look at how we're going to do that, what that means. That's what I want to focus on today, is these story problems. So why don't we start doing 33 in our notes? So right for 33, write C notes. Okay, we're just going to do that one right into our notes. That's a great question. So put this away, get your notes out. Okay, so today is the 19th. All right, so we are 4.2 continued. We'll start talking about GCF. All right, let's talk about story problems. So, as you guys noticed, I just want to make sure that I'm officially saying this, that it's something you guys already figured out. All right, so if you look at the wording, when we see that we have several data items, and we are looking for the greatest number of groups of the items, this is GCF. So if you're on a high school placement test, or you're on an SAT, or you're on anything, if they have several groups, several data items, the total number of flowers that we have, which is what we're going to be doing, and we're looking for the greatest number of those things in each group, or the greatest number of groups that I can have of those things, that's GCF. All right, so let's take a look at number 33 from page 182. All right, even if you got this right, you're all doing this. AJ, sit up. Even if you got this right, you're all doing this. All right, so we have daisies, and there are, we are counting by sevens, so 56, that gives us 73, I believe, right? 56 plus 7 is 63. So we have 63 daisies. We have lilies, and there were 56 lilies. We had irises, and there are 42 irises. And then we have freesias, and there were 21 freesias. All right, and we want to find the greatest number of bouquets where we will have the same number of each type of flower in each bouquet. So I have the same number of roses or daisies in each one. I have the same number of lilies. It doesn't mean I have the same number of daisies and lilies. It means we have the same, we're divvying up, we're dividing up those 63 daisies into groups. And each group is going to have the same number of daisies. Each group is going to have the same number of lilies. All right, so because we are looking for the greatest number of bouquets, where each of them, we have the same number of each, this is GCF. All right, so we need to do the prime factorization of all of them and find the GCF of all of them. I know you did this in your homework, but we're repracticing it again, and then we're going to do another one that's new. All right, so somebody do the prime factorization of 63 for me. Matthew? Excellent. Somebody do my lilies of 56. Somebody do that prime factorization for me. Patrick? Okay. Excellent. All right, somebody do my irises of 42 for me. Addison? Okay. Excellent. All right, and then my last one. Who wants to do my last one for me? Amanda? Excellent. All right, so I think you guys got the prime factorization part down. Now I'm going to list them. 21 is 3 times 7. 42 is 2 times 3 times 7. 56 is going to be 2 times 2 times 2 times 7. And then 63 is going to be 3 times 3 times 7. Did I forget anything? 7 times 3, 2 times 2, 2 times 3 times 7, 2 times 2, I'm just making sure there's no 3 in here. Okay, so it looks like we can make 7 bouquets. So my GCF is 7, or 7 bouquets. Alright, so that wasn't your question, Addie, but I want to make sure that I write that down properly. All right, so the question becomes, we want to know how many of each are in there. So I'm just going to freeze this, and I'm going to put it on my next page. So I have 63, we had 63 daisies. We had 56 lilies. We had 21, we have 42 and 21. So 42, 21, that's iris. and the freesia, and we have 7 bouquets. I'm just re-summarizing here what we have. All right, so we want to know the number of each of these, right? So I need to figure out my number of daisies in a bouquet. Well, it's going to be the same formula for all of them. It's going to be my number of flowers. This is when we would have, I'm okay with you just, because we don't necessarily need a game plan, I'm okay with you just doing division, is going to be divided by my 7 bouquets. Doesn't that make sense? So if I know I have 7 bouquets, don't I have to divide each of those groups up into, divide it by 7? Doesn't that make sense? All right, so for my daisies, I have 63 divided by 7, which is going to give me 9, right? So I have 9 daisies, and then I would do that for each of them. So I would go back and divide how many of the total of each individual one I have by however many groups of each one. Can I finish without your hand up? All right, so then I have 56 divided by 7, and then we would go from there. Does that make sense, Addison? Yes, Matthew. I just need you to come up with what you're doing. I just need you to come up with what you're doing. I'm not focusing on a game plan at this point right here. I'm focusing on finding it, but I do need to kind of come up with how you're going to find it. Does that make sense? Okay. You guys cool with that? Okay, so I want you guys to do another one. I want you to do this problem. So I want you to do that problem. Coral, did you get something to eat? Did you get some water? Feeling a little better? Bless you. Somebody say bye. See if you guys got the same answer. Help each other out. Process I'm teaching you. So really practice that process. Alright, so let's take a look at this. Okay. So we want to find the greatest number of groups. That's the first thing I want to do. All right, with the same number in each group. Same number of each. That's important to recognize. If they don't say that, then you cannot use GCF. That's how these work, is we want the greatest number of groups with the same number in each group. All right, so someone do the prime factorization of 24 for me. Go ahead, Brendan. All right, Danny, do 36 for me, please. Excellent. All right. AJ, do 60 for me, please. Excellent. What's the next step in this? Colin, what's the next step? Excellent. Awesome. That's okay. I always put it in order, but I suggest that, but it's okay if you didn't. Brendan, will you close that door for me, please, sweetheart? Go ahead, honey. Excellent. All right, Amanda, what's next in my step? So circle. I want you circling what's in common. They have a 2, okay? Put the chair down. They have another 2. And then my 3. All right, now what? Excellent. And what does that equal? That equals 12. So I have 12 groups. How many of you guys got that right? All right, how do I figure out how many sopranos? How do I figure out how many sopranos? Ada? All right, so what's that going to be? My 4 divided by 12, so it's going to give me 2, right? How about my tenors, Ada? It's going to give me 3, and then how about my altos? All right, so that's all the work that I should see. You guys cool with that? All right, so tonight you're focusing on story problems. Okay? All right, my odds, you may go.